Hello, my students. Now a new lesson in the gas laws. We're studying the effect of temperature of a gas on the volume at constant pressure. Now we are maintaining a constant pressure, and let's check the effect of temperature of the gas on the volume. Two bulb flasks and tightly closed, trapping carbon dioxide in one of them and oxygen in the other one. A bent tube, as shown, is enclosed with a thread of mercury like this to maintain constant pressure, as we are having a pressure in the right side equal to that of the left side, and I can repeat this for the oxygen bulb, right, like that. And then transfer this system into a container containing cold water. Then add hot water. Let's see and observe what will happen. The two mercury threads are equally expanded, which means that the expansion of gases are equal at constant pressure. The conclusion is equal volumes of different gases expand equally when heated through the same temperature rise. Again, two equal volumes of two different gases, and both of them were subjected to the same interval of temperature rise, so they expand equally. We came to an experiment to determine the volume expansion coefficient, which is the rate of increasing in the volume. We got three samples of gases. The first one is 273 centimeter cube. The second one is 546 centimeter cube. The third one is 819 centimeter cube. After raising the temperature by 1 degree, we observed that the volume increased to 274 centimeter cube. From 1 to 2 degrees, the volume increases from 274 to 275 centimeter cube, which means for every 1 degree rise temperature, the volume increases by 1, compared with its original volume at 0 degrees Celsius. Let's come to another values. 546 centimeter cube when heated from 0 to 1, it increases by 548. It increases by 2 centimeter cube. From 1 to 2, it rises from 548 to 550 centimeter cube. It rises by 2. Therefore, for an interval 1 degree in temperature, the delta volume becomes 2. The volume at 0 is 546. So delta V is 1 compared with 273, delta V is 2 compared with 546. Repeating the experiment with 819 centimeter cube, it increases for the first temperature degree rise to 822, the second one to 825. Therefore, the change in the volume equals 3. Imagine that it's the same ratio, knowing that 546 is double 273 and 819 is triple 273. Therefore, delta volume over volume at 0, which is the initial volume over delta T, in the first case is 1 over 273. The second one is 2 over 546. The third one is 3 over 819. This means that the volume expansion coefficient, the alpha V, which is the ratio between the delta volume for every change in temperature with respect to the volume at 0, is 1 over 273. This is a constant value. The delta volume in meter cube the volume in meter cube. Therefore, alpha V equals 1 over Kelvin or 1 over degree. Definition: it is the increase in volume per unit volume at 0 degrees Celsius for 1 degree rise in temperature. This means that a volume of gas increases by rate 1 over 273 of its original volume at 0 degrees Celsius for each 1 degree rise in temperature. But do not miss that. Keep in mind it is at constant pressure. Note, 1 degree rise in Kelvin equals 1 degree rise in Celsius. Here we go for the study of the relation between volume and temperature at constant pressure, which is Charles' law. Charles got a capillary tube and he put a mercury thread like this to enclose a gas in this part. Then he get a glass envelope like this. He used the thermometer to measure the temperature and made an inlet and outlet as shown. At the first, he pushed a crushed ice over here to decrease the temperature of the enclosed gas to 0. We will notice that the mercury thread is going down, which means the gas inside was shrinking due to the decrease in temperature. He repeated the experiment many times with different intervals of time. He used warm water, he used boiling water, and so on. For every time he took the reading of the volume for the increase in gas volume, and he took the reading for the increase in temperature. He plotted the relation as the following: the volume at 100 degrees Celsius, the volume at 0 degrees Celsius, and connected them by straight line and make an interpolation like that. He found that the line intercepts the x-axis at negative 273. How marvelous this number is. The negative 273 is the point at which the graph indicates that there is no volume. But keep in mind, it is theoretically. Charles' law. He said, according to the relation of the alpha V, the coefficient of volume expansion, delta volume over volume at 0 times delta V equals 1 over 273, that the change in the volume is 1 over 273 of the volume at 0 for the change interval in temperature. He stated that at constant pressure, the volume of a given mass of gas changes by 1 over 273 of its value at 0 degree per each degree change in temperature. That was all for today. Thank you. Bye.